Lesson 7.6, Implicit Differentiation Level 1. So what is this implicit differentiation? Well, we've already heard of differentiation before. It's taking a derivative or finding a slope. So in implicit differentiation, you're taking the derivative of each side of an equation that has two variables, usually x and y, by treating one of the variables as a function of the other, kind of like a function composition. And so the name of it actually comes because there's two types of equations, and we learned this in pre-calc. There's explicit equations and implicit. Explicit equations are solved for y, or maybe they start with f of x equaling something. And so we never had to worry about a weird differentiation because we always had x inside of here. But implicit equations are equations like a circle. This is the equation for a circle, where you have x and y within the equation, and you have to then use implicit differentiation. So let's try number one. We've got this equation here. It's set equal to 0, which sometimes it is, sometimes it isn't. Find dy over dx in terms of x and y. So what I want to do is I'm going to rewrite the equation, and I'm going to take the derivative of both sides. And so really, I just go ahead and put one set of brackets, and I'm going to take it times d over dx. I don't want to put dy over dx because I'll actually end up with that once I take the derivative. I'll show you what I mean. So for negative 3y squared, notice how we're taking the derivative with respect to x. So this is not x, so this is when implicit differentiation takes place. So take the derivative like normal. Negative 3 times 2 would be negative 6y. And then since I'm taking the derivative of y, that would be dy over dx. Okay, and then the constant goes away. Derivative of negative 5y cubed, same thing, would be negative 15y squared. But since I'm taking the derivative of dy, or of y, it would be dy over dx. And then minus 6x, and then it's like I'm taking the derivative of dx over dx. I'll never write this in the future. I just want to show you again that that's really happening, which is just 1, and that's why we don't have to do it. And of course the derivative of 0 is still just nothing. Okay, so now what I want to do is actually rewrite. I don't really like seeing dy over dx in my equation. I think it looks more confusing in a fraction. So I'm going to replace it with y prime. Y prime is just saying the derivative of y. So y prime. Okay, so now we're going to figure out, though, how do I solve for that y prime? How do I get it by itself? Well, it's happening in two different terms. So what I'd like to do is keep all the terms that have y prime on one side and move anything that doesn't to the other side. So I'm going to add the 6x. So that'll get me negative 6y times y prime minus 15y squared times y prime equals positive 6x. Now I'm going to factor y prime out. So I'm really dividing it out, but I'm going to factor it out. So then what's left over is times negative 6y minus 15y squared. And then since this is multiplication, I'm going to divide this negative 6y minus 15y squared away on both sides. So y prime equals this. I'm probably not going to write it again, but that is what dy over dx would equal. It's saying as x is changing, y is changing within here. Okay, let's try number 2. Okay, I'm not even going to rewrite the problem again. I'm just going to put brackets around it. And I'm going to take it times d over dx. So I'm taking the derivative with respect to x. So anything that's not x is going to have to be treated special. So this would become negative 3x squared minus 2, because really the y would go away. But since I'm taking the derivative of y, I'm going to get that dy over dx, or I'm going to go ahead and write y prime, plus 4y, and then I would need times another y prime, minus 1. Equals negative 9y squared y prime. So basically anytime you're taking the derivative of y, you're going to get a y prime. Now I see all these terms and I want to specifically look at the ones that have y prime. I want them on one side. So I think I'm going to keep negative 2y prime, keep positive 4y y prime, add 9y squared y prime. I'm going to add 3x squared to the other side, and I'm going to add 1 to the other side. Then I'm going to factor out the y primes. And so that would be times negative 2 plus 4y plus 9y squared. And I'm going to divide by that. And so that would be your answer, 3x squared plus 1 all over negative 2 plus 4y plus 9y squared. And in the future, what that's going to allow us to do is then be able to have an ordered pair at point, an x and a y, plug it into this equation, and get us the slope at that point.